Good morning, class. This is Mr. Eggleston. This is lesson 4.2, Interpreting Solutions to a Linear System Graphically for Algebra 1. All right, so lesson 4.2 is about basically what does it mean to be a solution to a system of equations. We already saw that we found points that were common to both equations from lesson 4.1 that satisfy both equations. Graphically, what does that mean? Basically, what that means is we are going to graph both equations and see where they cross. And where they cross, that's the solution. If they don't cross, there are no solutions. And if on the rare occasion that you graph both equations and it turns out to be the same line, we say there are infinitely many solutions. Basically, every point on one equation is a solution to the other equation. All right, so we're going to understand that a solution to an equation is any ordered pair that is on its graph. That's a solution to that equation. That's why we graph them in the first place. It gives us a picture of all possible solutions to that equation. All right, and the solution to a system of equations is the ordered pair that lies on both of the graphs, basically where the lines touch. Okay, and then the last learning target is explain what the graph of a linear system looks like with zero solutions, one solution, or infinitely many solutions. Well, I've already kind of stated it. Zero solutions is where two lines don't cross, and we usually call those parallel lines. One solution is where two lines are touch at one point, and infinitely many solutions is when you graph both equations and it turns out to be the same equation. You got one graph. Okay, by describing the slopes and y-intercepts of the equation. So, and we'll get into it. It's pretty straightforward. In math class, we solve lots of problems. But are there some problems that don't have a solution? Well, we'll start by looking at the line y equals 2x minus 5. Give the ordered pairs of at least 4 points. Well, I'm going to say 0, negative 5. I'm just plugging in, let's go with 1. 1, negative 3. All I'm doing is plugging those numbers into this equation here and evaluating. All of you should be comfortable doing that. We could say 2, let's see, 2 times 2 is 4, minus 5 is negative 1. And we could say 3. 2 times 3 is 6, minus 5 is 1. There are 4 points. Now graph the line. So over here on this grid, we'll graph the line, the point 0, negative 5, which puts us down here. 1, negative 3. Notice I went over to the right one and up 2, over to the right one, up 2. I don't have to plot. I'm using slope because the slope of this line is 2. Okay. That's 2, negative 1, 3, 1. And if you want to, over 1, up 2, we could be there. Over 1, up 2 gives us that. So we got all these points. All right. They only wanted you to list 4 and then graph it, but I put down all the points using the definition of slope as rise over run. Okay, and there's my line. Okay, is the point negative 17, negative 39 on this line? How do you know? Well, you check it out by plugging that point in. That is, it was 2x, and x is negative 17, minus 5. Does that equal negative 39? That's the question. That's how you'll know. So let's see. This equals negative 34 minus 5. And sure enough, it equals. So yes, it's a solution. Yes. Negative 17, negative 39 is on the line because it satisfies the equation. Now they're asking you to consider a new graph, and I'm going to have to shrink this down. 7 is a bit big. List some ordered pairs of points that are on this line. I'm going to use the color green. So this is y equals negative 1/2 x. All right? List some ordered pairs. Well, let's go with our usual. Let's go with 0. When x is 0, y is 0 because 1/2 or negative 1/2 times 0 is 0. Now, here's the key. I'm choosing even values because I'm dividing by 2. I'm multiplying by 1/2. If I choose odd values of x, I'm going to have fractions, which is most students will say it's a pain in the butt. So let's go with 2, comma. Now, 2 times 1/2 is 1. 2 times a negative 1/2 is then negative 1. Okay? And let's go with 4. 4 times 1/2 is 2, and negative 1/2 times 4 is negative 2. And then let's just go negative side. So let's go negative 2. Half a negative times a negative is a positive, so 1/2 of 2 is 1, so we have that. So we have the points 0, 0, 2, negative 1. Oh, look at that. That point's in common. 4, negative 2, and negative 2, 1, just to go in the opposite direction. Let's connect the dots. When you were kids, I'm sure that was one of your favorite things to do. And you have this. These two lines. And these two lines cross at exactly 1 point. Are there any points that are on both lines? If so, which ones? Yes. The point 2, comma, negative 1 is on both lines. Okay. Now, let's think about the line 6x minus 3y equals 15. Now, one thing I do know, this little bit that's on top of the grid is going to have to be moved because it's just going to be in the way. So I'm going to move it over there. Okay. Just so that we have space, because they're going to ask you to graph this, I'm sure. Okay, it says find the x and y intercepts of this line. Well, here's our equation. Let's see. That was blue, so let's make this yellow. So find the x and y. Remember, x-intercept is when y is 0. So we're looking for that. That's the x-intercept. And the y-intercept is when x is 0 and we're looking for y. And that's the y-intercept. So looking at this equation, you may remember this from your nightmares because a lot of you guys did not like this. So if we let y equal 0, that means the negative 3y goes away and we have to solve 6x equals 15. All right? So 6x equals 15 says that x equals 15 over 6, which reduces to 5 halves. So or 2.5. So the x-intercept is 2.5 comma 0. Okay? That's 2.5. Okay? The y-intercept is when x is 0. So I'm going to erase this because that's how we found the x. I mean, it really is easy. You just, for the x-intercept, for the y-intercept, we are just going to let x equal 0. And we have negative 3y equals 15. Okay? Or y, negative 3y equals 15, or y equals negative 5. So 0, negative 5 is the y-intercept. It says find the slope of this line. Okay? Well, to find the slope, we go rise over run. Okay? Which is, if you look at this, there's negative 5, 0. We go up 5, the rise is 5, and we go to the right 2.5. And that equals a slope of 2. Okay, find the slope of this line. Again, I just looked at this point and this point right, well, actually, and then 2.5 is right there. And if you really look at this, you can see that they're the same, that white line, which is above, which is this right here, y equals 2x minus 5, is the same as this line, because it's the same graph. Okay? Are there any points that are on this line and also on the line 2x minus 5? If so, which ones? Well, same slope and same y-intercept means same line. So every point on 6x minus 3y equals 15 is on the line is on y equals 2x minus 5, because they are the same line. They have the same slope and the same y-intercept, and if you were to plot them, they would be on top of each other, as is indicated by this. Okay? Above in a different color, what do you notice? Okay, it's the same line. That's the tricky part of the standard form, because you can just multiply everything by a number, which means everything's scaled different, scaled up the same way. It still gives you the same line, even though the equation will look different. Okay. Then the last statement is use a different color to graph a line that shares no points with y equals 2x minus 5. Okay, no points with y equals 2x minus 5. Well, notice I'm just going to go, can't do it that way. Let's see. Up 1, 2 to the right 1, up 1, 2 to the right 1, up 1, 2 to the right 1, 1, 2 to the right 1, 2 to the right 1, 1, 2 to the right 1. And you can see right here, that blue line shares no points with y equals 2x minus 5. Notice that about the slope and y-intercept, well, they both have a slope of 2. So they both have a slope of 2, which is same slope. But they have different y-intercepts. Okay. So let's go back and start kind of filling in a few things. Okay, going back here. Every point on the line is a solution. On the line is a solution to the equation. Okay. So that's number one. We saw that for C, yes. Negative 17 comma negative 39 satisfies the equation. Okay? Thus, it is a solution. Number 2, C, any point on both equations, on both graphs, both lines, satisfies the system. The system. Okay. Now notice, it's the same y-intercept. And same slope as y equals 2x minus 5. Okay. So our system would have been this, y equals 2x minus 5 and 6x minus 3y. If that was our system, equals 15. The system would have infinitely many. Has infinitely many solutions. Okay. And the last one is they both have a slope of 2, same slope and different y-intercepts. That means lines that are parallel, have let me restate it a different way. Linear systems, because what I was writing was kind of long. Linear systems with no solution are parallel. Are parallel lines. Okay? And there you go. Now here's the takeaways. A solution, XY, I'm just reading this. You copy this down. A solution, XY, to a linear system satisfies both equations in the system and is on the graph of both equations. Intersection point, all right? So that's what we mean. When we solve a system, we're looking to see where two lines cross, all right? A linear system can have 0 solutions like this, parallel lines, right, that never touch. 1 solution, which is like this one, where it's 2 lines with different y or different slopes that intersect at one point, or infinitely many solutions, which are coinciding lines. In other words, they're the same line. The equation looks different. All right? And that little symbol there means infinitely many. Infinite. Okay? So that's it on this, and then I'm going to do the check your understanding in a separate video.